Is it possible to build a city on the moon? NASA and Roscosmos made parallel announcements about cooperation to build the new lunar orbiting space station very recently. NASA has been working with its partners to build a new space station, and everybody's thrilled now that Roscosmos, the Russian space agency, has joined in the fun. On October 19, 2017, scientists reviewing some data from the former Japanese Kaguya lunar satellite, which crashed onto the moon in 2009, revealed a 50-meter hole in a formation called the Marias Hills. Further study by radio waves has revealed that this is, in fact, a lava tube formed about 3.5 billion years ago. It's 50 kilometers or 30 miles long and would likely make a great settlement for early explorers involved in building a more sophisticated city. Since the moon has only a trace of atmosphere, it provides no protection from radiation or meteorites. An underground lava tube would keep the inhabitants safe from such dangers. Lava tubes are formed when molten rock pours through fissures, creating a circular tunnel. When the lava flow stops, the tubes drain, leaving a flat floor and a strong arched roof. Such tubes exist here on Earth, but on the moon, they are much larger. They're likely a kilometer tall and wide, so combined with their length, could easily fit any of the Earth's largest cities, including all of its tallest buildings. Scientists, researchers, construction crews, and everyday citizens would be safe from the hazards of space in there. For a number of years, stories have been circulating about building a dome over the crater named Shackleton. It's 40 kilometers or 25 miles across, and at the center, it would be 1,500 meters tall. The enclosed surface would provide uncrowded living area for almost unlimited numbers of people. The glass roof, made from lunar silica, would be supported by titanium and aluminum frames, but narrow enough to be almost invisible from inside on the ground. Even though several meters thick, in multiple layers to control thermal expansion and contraction, it would still be transparent. If a meteor did happen to strike the dome, it might take out 1 to 4 panels based on the largest meteor predicted and whether it struck a single panel or a junction between 4 of the hexagonal-shaped panels. The air leakage would be very slow because when you have about 40 cubic kilometers of air and a tiny hole, it would be hours before the pressure change was noticeable. It could be days before there was significant loss. There would be plenty of time to repair it. The fastest strategy would probably be a giant Kevlar beach ball that could be placed over the breach and be held in place by the air pressure inside the dome while a repair was executed by an external team composed of the original robots that built the dome. Beneath the surface city would be a subterranean city containing infrastructure. This is a leftover of where the original inhabitants and construction workers lived before the dome was complete. It would contain living space sufficient for all residents in the event of a catastrophic dome failure. In the case of a very large hole, cryogenic coolers could rapidly condense the atmosphere inside the dome to a liquid state, saving as much as 80% of the atmosphere until the dome could be repaired. It's a small possibility, but one worth being prepared for. Using automated construction, both for safety and speed, such a dome could be built in 15 years provided the lunar mining operation was in full swing. Some medical researchers have suggested that under the influence of lower gravity, the human lifespan might increase to 150 years, so it could make an excellent retirement place. Such an enclosed crater would have an area exceeding 1,250 kilometers squared, or 485 square miles, or a little more than 20 times the size of Manhattan Island. Not only would it make a fine place to live, it could take decades to fully explore. Looking at the image above, you might also note that almost 20% of the crater is taken up by a central lake about 5 times the size of Manhattan. We could fill it by mining ice from permanently shadowed craters located around the moon's poles, and it would serve as a central reservoir for the entire city, supporting aquaculture food as well as fish populations. With all of Earth's entertainment resources only 1.25 light seconds away, there would be no reason not to have any sort of entertainment that was available on the home planet, including theaters. With only 1,250 millisecond delay time, you could still log into the internet and play MMORPGs with your Earth friends if you desired. This is completely unlike Mars, where the time delay is dependent on where both planets are in their orbits. There, the delay could be as little as 4 minutes, but as much as 24 minutes. More interesting is that lunar gravity is only 1/6 of Earth normal gravity. Simple fabric wings would be sufficient for a reasonably healthy person to fly under their own power. A small electric motor could make it effortless, slow, and silent, whereas a bigger one could make it fast, competitive, and noisy. The moon has other advantages, in that far side is completely shielded from all the electromagnetic emissions of Earth. It would make the ideal location to perform radio astronomy. Optical astronomy from just about anywhere on the moon would be fantastic too, since there would be no atmosphere to interfere with viewing. Fusion energy is making great progress lately. One promising possibility is the element called helium-3, which is plentiful on the moon, because it has no atmosphere and the solar wind deposits it there. We have very little on the Earth, but just 25 tons could power an energy-hungry country like the United States for a whole year. Countries like India, China, Russia, and others have all expressed interest in mining the moon for this material. Even private industry is getting on board with people like James Cameron, Larry Page, and Eric Schmidt using their company Planetary Resources to get the ball rolling. NASA is conducting research too, so this is serious business that will make the next generation's billionaires. At $3 billion per ton, there is plenty of reason to go after this non-radioactive fuel for nuclear reactors. Of course, we don't have to start with such a large crater that would take so many years to complete. The small one, just 5 kilometers across, would provide 20 kilometers squared of living area. Hydroponic food growth complexes, where a 1-hectare facility produces as much as a 100-hectare earth farm, will leave all that land available for things other than crops. Such a facility could be built by a hotel chain conglomerate, making it a vacation destination that was out of this world. Not fantastic enough on its own, soon you could expect that they would challenge to sponsor the lunar version of the Olympics with the 20-meter pole vault, the 2-meter hurdles, and the 10-kilometer endurance human-powered flight race. The floor work for the gymnasts ought to be incredible, but for safety's sake, maybe we should skip the shot put in the javelin toss. The most important job for humanity right now is to get a large, sustainable population of human beings off of this single planet. Our planet exists in the middle of a cosmic shooting gallery. If it wasn't for Jupiter and the other gas giants sweeping up the larger rocks before they enter the inner solar system, we would be subject to devastating asteroid strikes much more often. The old adage about having all your eggs in one basket is dangerously applicable to the human race. We might be able to deflect a large rock heading for our planet that could destroy all life. We're the first Earth life that is intelligent enough to be able to detect such a thing and do something about it. The fact we're making so little effort in that direction should frighten everybody. Building a city on the moon is not only a fantastic idea scientifically, but one of the best things that we can do to assure the survival of our race in case there is an asteroid heading right for us that we haven't detected yet. Remember what happened to our dinosaur friends.